welcome to another Algebra 2 video. In this video we're going to be looking at exponential functions. We're going to look at first the key features, and then we're going to go into evaluating, solving, and things like that of exponentials, and probably start looking into logs. So in this video we're going to be in the Savas Algebra 2 book. We're going to look at topic 6. Lesson 1, example 1, and I'm going to use this as my reference as we go through these videos. So let's start with my exponential function. What does an exponential function look like? So we have some function f of x, and it's going to equal a times b to the power of x, where a and b are constant values. All right. Some rules to this is a cannot equal 0. B has to be greater than 0, and b cannot equal 1. If a was equal to 0, then we would have 0 times anything is 0, so this would end up being 0. B needs to be greater than 0 because we're looking at a graph that's growing. We're looking at something that will have even exponents. And when you have an even exponent, you can have a negative base, because that would be positive and we'd be jumping and we wouldn't have a consistent graph. We would have holes in our graph as we go up. So b has to be greater than 0. Then b cannot equal 1. If b is equal to 1, then we just have the value of 1, because 1 to any power is going to be 1. So we will have a constant. That doesn't mean it's not a function. It's not a function of the constant 1, but it will still just be the function of the constant 1. So these are three kind of hard set rules that we need to follow for an exponential. All right, the next thing that we need to think of is the parent function of an exponential, f of x equals bx, is we need to look at the base. So if the base is greater than 0, the base is greater than 1, then we have a certain type of domain. So my domain, actually the domain is the same for both of them. The domain is x. X is all real numbers. The range is actually the same for both. So my range is going to be y. Y is greater than 0, and I'll graph this out so you could see using 2 as my base. The y-intercept for our parent function of b of x, where b is greater than 1, is going to be y is equal to 1. That's my y-intercept. My x-intercept we actually don't have. We get closer and closer to the x-axis, but we never touch it. So we have a horizontal asymptote in this one of y is equal to 0, which means we're going to get closer and closer and closer to that x-axis. We're not going to touch it, cross it for this parent function of b of x. And so that means that my end behavior it's an h. If I look at this, as x approaches negative infinity and x approaches positive infinity, and I'm going to draw out the graph here for you. So here's my x-axis. Here's my y-axis. And my graph would always look something like this, where this is 1, and it doesn't matter what the base is. As long as the base is greater than 1, you're going to cross that 1. So what we're looking at here is we're looking at the left side. The left end behavior will keep kind of going closer and closer to that x-axis, but it will not actually touch or cross it. So my end behavior is what we're approaching, and we're approaching the value of 0. So we have that horizontal asymptote. This is where you also start thinking of limits. We're getting limited to 0 and above. On the other side, on the flip side, as we go positive in our x, we're actually going positive in our y. And we're going to go all the way up to infinity for our y. So the book uses the example of 2x. 2x will follow this same pattern. 2x will have all of these same values. Even if I did 3 to the power of x, we would still have the same domain, the same range, the same y-intercept, just as long as we follow b to the power of x. Okay. So the second one, the second part of this is if f of x is equal to b of x and b is less than 1 but greater than 0. So we're looking at fractions. Like the book itself uses 5 times 1/2 x. And if I looked at what happens with 1/2 x, we're going to start looking at the exponential properties. So if I were to look at the 1/2 to the negative 1 power on my graph, this is actually saying if I want this to be a positive exponent, I have to take the reciprocal, or 2 to the power of 1. Well, that means that when we're on the negative x, we're actually looking at whole numbers. When we're on the positive side of x, we're looking at fractions, which means we go from the first one wasn't that straight, but I could get this a little bit straighter. We're looking at something that's shaped like this. So this is for b being a fraction, a decimal between 0 and 1. All right, so in this case, my domain is still the same. X still populates on all real numbers. The range is still the same. We still are approaching 0. We're getting closer and closer to 0, but my range still is 0 and above. Y is greater than 0. We never get to any negative or even y equal to 0 values. All right, my y-intercept. My y-intercept, as long as we're not looking at that A will actually change your y-intercept. But my y-intercept is y equals 1. And then my asymptote is still going to be y equals 0. And my end behaviors here kind of switch. I don't know why I put the curly brackets there. I meant to say end behavior. As x approaches negative infinity, though, we see that this goes up to infinity. So we have y goes to infinity. But as x goes to infinity, we get closer and closer to a horizontal asymptote of 0. So y approaches 0. Okay, if I'm looking at this case of 5, so if I'm looking at f of x equals 5 1/2 x, this actually changes our y-intercept. Remember when we're calculating our y-intercept, or when we're calculating our y's, we're looking at our vertical stretch. This is a vertical stretch, which means I'm going to take the value of y before, which before my value of y was 1. I'm going to multiply it by this value, which is 5. So my new y-intercept is now equal to 5, or in our case, a. So something to look at when you're looking at the different pieces and parts of an exponential function, on how all these things come together. All right, so I will catch you in the next video. Again, if you have any questions, please feel free to contact me via email or Remind, and I will catch you in the next video.